So let's start problems in chapter 10. I have here the number of defects and number of opportunities. Number of opportunities are loans that I am processing as a manager. I'm looking at the number of applications and I'm processing it. The number of applications is 1,000. Out of that 1,000, I'm seeing that there are some loan applications which were wrongly filled by the applicants, and that is 150. So I'm calling them the defects. So the DPMO, or the defects per million opportunities, is going to be equal to 150 divided by 1,000 multiplied by 1 million. And there is 150,000. This is the number of defects per million opportunities. So that's how you calculate the DPMO. And the equation is given here. The mean here is 61. The upper limit is 65. The lower limit is 55. The standard deviation is 2. So now I need to find the process capability index. The equation is here. So let's calculate. There are two terms here. One is this term, another one is this term. So let's calculate the two terms. The first term is going to be mean, which is 61, minus LSL, which is 55, divided by 3 times sigma, which is 2. Okay, and that comes to 1. The other term is USL, which is 61 minus, USL is 65 minus 61, which is the mean, divided by 3 times sigma, which is 2, and that comes to 0.6667. So the minimum of these two, that is going to be minimum of this comma this, is your answer. So the answer is 0.6667. Okay, and that's how you calculate the CPK. Let's look at the X bar chart and R chart. I have this data here. I have sample numbers. I'm taking about 10 samples, and there are 5 observations. These are 10 samples and 5 observations. I get this X bar. X bar is equal to the average of this. Range is going to be equal to the highest number here minus the lowest number, which is in this case 10.60 minus 9.90, which is 0.70. So I calculate all the X averages, I calculate all the ranges, and then this is the average of all the X's, and this is the average of the range. So this is going to be my X bar. This is going to be my R bar. Okay, so this is my X bar and this is my R bar. So I can, if I want to, I can take the X bar samples and I can take the R bars, the X bars, and I can go and draw a chart basically. This is my chart. This is my X bar chart. Okay, and here I can find the mean, which is going to be 10.21. So I can draw a line here. and that line is 10.21. And this is my mean. Okay. So now I have drawn the whole thing. This is my mean, and these are the points. I need to find this is the X bar chart. So I need to find the UCL and LCL. For the UCL, I need to go to this figure. This is Exhibit 10.13 in the book. So I have 5 observations. In these 5, if I go to 5 observations here, 1, 2, 3, 4, 5, and then go across, I see that my A2 is going to be equal to 0.58. So it is going to be equal to the mean of the units. The mean of the units is how much? So the mean of the units is given as 10.21. So that is going to be equal to 10.21 plus A2, which we said it is going to be 0.58, 0.58 times the mean of the measurement differences is 0.43, 10.46. The LCL is going to be equal to the mean of the units minus A2, which is 0.58 times the mean of the measurement devices, which is 0.43, and that is 9.96. Now I can see, I can make a line here as the UCL and LCL. So let's insert that. So the top one is 10.46, which comes to a little more than that. So I'm going to put it over here. And the other one is 9.96. 9.96, which is below, somewhere below that, right? Somewhere below that. So now this is my UCL and this is my LCL. All my data is within this UCL and LCL, so my process is good. So the process is good. So let's find out the X bar chart. So we have drawn the X bar chart. This is the mean, okay, which is the line where I got this from looking at the mean, which is all the way down here, 10.11, right? That's the X bar, which is the mean. So let's find the UCL for X bar. The UCL for the X bar is going to be equal to the mean of the units, which is 10.21, plus A2, which is, if I go across 5, I find A2. And that A2 is going to be equal to 0.58. So 0.58 times. If I go across the same line, I can find D3 and D4 as well, but I do not need that for my X bar. So the next thing is multiplied by the mean of measurement devices, which is 0.43. The LCL is going to be equal to the 10.21 minus A2, which is 0.58, which I looked at, times the mean, which is 0.43. That comes to 9.96. So if I want to draw a line here, I can draw 9.96 as a lower, which is actually very low here, somewhere here. And then I can draw another line, which is the upper one, which is 10.46, which is somewhere here. Okay, so this is my UCL and this is my LCL. All my data is within the UCL and LCL, so therefore the process is good. Similarly, I can find for R. I can draw the points for R using these data and the mean, which is also given here. The mean R. So I can draw the similar chart. After drawing the chart, I need to find the UCL for R. The UCL for R is simpler. It is going to be equal to the D4, which is, if you look at the D4 here across 5, it is 2.11 from this figure. So 2.11 times the mean of the measurement devices is 0.43. That is my UCL. My LCL is going to be equal to, it is actually 0. D3 is 0, so 0 times, of course, it's going to be 0, right? 0.43, and that is going to be 0. So this is my UCL and LCL for the R chart. So that's how you find the X bar chart as well as the R chart. Okay. We will now next move to chapter 11.